Hey everyone, so this is question 8 in section 13.3, measures of variation within the linear regression single factor. Okay, so the spirit of this question is trying to predict the starting salary of the MBA students, and they're going to use as a predictor the tuition per year, all right, as a predictor for starting salary. So basically how much they paid for their tuition and how much they are getting paid once they graduated. All right. So what they give you here, they give you the y hat, the equation, they give you sigma yi squared, and sigma, and the sum of xi, yi. So the purpose of this, they want you to calculate r squared using this formula, which is the SSR, sum square regression, divided by SST, sum square total. And the SSR, you can see it here, you can calculate with this complex formula over here. And this is kind of the long way, right? So you don't want to use these formulas, right? So you are supposed to plug in these variables here and here. Once you get these two values, so you plug them into here and you get the r squared. Now there is a better way, and the best way is to click on the data. Since they provide you the data, just download it into Excel. All right, and this is already has been done. So once you download the data in Excel, you need to identify what are the x's and the y's. Since we are using the predictor, the tuition, this is going to be your x values, and as you are predicting the values of the salaries, so this is going to be the y value. So there you go, we identify which and which. Now the best way to do it again is to go to data and run the regression data analysis. So data analysis, you select here regression from the menu, and you have to scroll all the way down so you can see it there. And once you open it, so they're gonna ask you about the y range, and the y range, you click here and you select including the labels all the way down. All right, and for the x input, you're gonna do almost the same thing. So you can do this. You can as well select the first cell, which is the label here, and then shift control and arrow down, that's you're gonna select all the data below it. All right, or just grab it. All right, now did you select the label? Yes, that's the first cell. That means is not numerical values. And we don't choose anything else here, we just make it simple. We're gonna just go to the output range in the same spreadsheet. You gotta click on here and then open this window and select where you want to have your output, and let's select it at the beginning there, and that's all. So you run your data, and here you go, you get everything. So let's make it a little bigger here. Okay, so the r squared that you are looking for is this value right here. You don't really need to do anything else. So what you want to do, you want to copy it, all right, and go back to your problem and paste it. And you want to round to 4 decimal places, so it can be 0.76746, so it can be 7675, and that's it. We got it. All right, so here is asking you for the explanation of the r squared. So what the meaning of the r squared? So this is a paragraph from your book, and where you can find the coefficient of determination explained. So what is the coefficient of determination, which is the r squared, is the proportion of the variation of the y that is explained by the variation of the independent variable x. All right, in other words, if I get, for example, here the example they are giving you, r squared is going to be 0.8479, it means that 74.89 of the variability of the y value, all right, depends from the x value. All right, so here if I'm gonna do this, So in your example, it's going to be 76.75% or proportion of the salary, starting salary, is explained by the tuition. So the tuition being X and starting salary being Y. All right. So we're gonna look for a similar explanation like this. Is the proportional variation starting salary that is explained by the variation in per year tuition, and I think A will be fit our description. All right. And right now they are asking you about the SYX, and again the SYX, you have a formula here which you can use. There is nothing wrong with that, or you can go back to your data analysis test and you select the standard error. So this is your standard error that you're looking for, and let's copy it and paste it. And they want you to round to 2 decimal places, so it's going to be 0.2749, which is 0.27. all right, we good. Now, seeing the value of the r squared, all right, so here again, all right, to explain this, we can make this scale. So this is the r squared. The r squared, it can be either 0 or 1 maximum, all right. So the closer we are to 1, so 0.75, all right, here you're gonna be giving us a good prediction. The closer to 0 with 0.25 here and below, all right, this giving us a bad prediction. So this is a good prediction or bad prediction, bad here and good here, right? So with the meaning of a good prediction, bad prediction, it means a good model versus a bad model, all right? So seeing the r squared here, you're going to be 0.76, all right, 75, that is close to 1, all right, is not equal to 1, is fairly close to 1. Now the regression model is very useful, yes, all right, that's it.